NVIDIA is the king of gaming because they've made this CUDA layer so that it works with really old GPUs from 10 years ago and something new in the future. Now, for ML and AI, you don't need all that stuff. You just need to figure out how to parallelize your work so that it runs as fast as possible. And if you bypass CUDA and go back to the driver, you could do it if you have the expertise. But in reality, most programmers don't have that expertise. I mean,
Welcome to Practical AI, everybody. My name's Jeff. I'm here with Peter Lin. Practical AI is brought to you by Pocket AI. Pocket AI is a visualization tool that allows you to prune your models without any loss in accuracy. Visualizing your model weights is like a brain surgeon being able to find individual neurons and removing them without harm to the brain. Similarly, Pocket AI allows you to analyze and prune the weights in your model. Using Pocket AI, we have proven we can select the right backbone model, get that model to actually work, make that model more stable, increase a model's accuracy, decrease the size of a model by up to 60%, and put smaller models into production for half the cost. Finally, you can be done with endless brute force training and new model trials. Pocket AI allows you to perform brain surgery on your existing models, making them not only smaller, but better. Peter, we wanted to talk about a really, really cool thing that's happening on the sort of operating system level, software level. But first, OpenAI, we kind of have rip on OpenAI almost every time we're together, but here they show up again. They're apparently raising money, and based on how much they're raising and who's involved, it looks like this valuation is creeping up to $830 billion.
yeah.
This can't keep going on, can it?
No, it's just ridiculous at this point. It's just completely nonsensical.
Yeah, I mean, I don't even want to talk about it because it's just, it's off the
Yeah.
charts how dumb this is. But, it's almost like they've gotten to the point where they're not only uh, too big to fail, but maybe even too big to succeed at this point. Like it's like inverted.
Yeah. Yeah. I mean, it's clear that they're trying to suck up all the resources and basically suffocate everyone else. To just put it bluntly.
Yeah, but if they don't do that, I just don't see a way that they can generate profit to be able to make up what
Oh
they've
no, they
spent.
can't. I mean, we know they're not profitable. We know that the cost of running ChatGPT now is more than they're bringing in revenue. So they're in the negative. They haven't said exactly how much in the negative, but they're definitely in the negative. They're not
Yeah.
making a profit.
Well, let's get off that because it's annoying, actually. Really, really cool story. Give us the landscape because the story of this story is actually pretty cool. So tell us what happened.
So Modular is this company started by Chris, the guy that created LLVM. And so if you're a programmer and you know compilers and you like to write languages, you know LLVM. It's used by Rust and a couple other languages and actually many languages. And basically, he started a company called Modular, where they decided to write a new language that's very Python-like, so it's Pythonic in that sense. It's the same syntax, but it's a superset, meaning it does more than Python. And then they have different frameworks. That they have Max, which is their inference framework. They have Mammoth, which is their kind of server framework for distributing workloads. And the great thing about Mojo is it'll take your code and it'll parallelize your code to the specific hardware you're running on, be it CPU, GPU, TPU, Grok, whatever. And so this article is about how the team was invited to present something for AMD to show off the new MI355, but they had 2 weeks to do it. And they managed to optimize the performance in 2 weeks, which is unheard of because if we think about games, every time NVIDIA or AMD releases a new GPU, it normally takes 6 months to a year for a game company to optimize the performance for that new chip. Typically. I mean, some smaller shops that have brilliant programmers might be able to do it in 1 to 2 months, but not in 2 weeks. That's unheard of.
So just, so I can explain this from my perspective in a way that maybe others can understand. So essentially, your models have to run on software which runs on hardware. And so we've talked about CUDA. We've talked about, I think, can't remember the other, uh, not the one that was on Grok, but anyway, we talked about some of the software that this stuff runs on, and it's not easy to rebuild your model if you had to use different hardware. And so their idea essentially was, well, no. If your model runs on Mojo, we're going to make Mojo run on all hardware. And the story is essentially they got access to a new bit of hardware and they basically built from underneath the covers the connections from what they do above works with your model all the way down to the metal of the hardware. And they did that in 2 weeks.
Yeah. So typically, like in the case of NVIDIA, when they have a new release, they update CUDA so for example, the Broadwell line of chips is very different than the previous two generations. And they actually removed a lot of the graphic stuff because Broadwell is really focused on AI stuff and not so much on graphics. But to the programmer, when you're writing a program to use CUDA, you don't know and you don't care. You just expect it to work. But the downside is CUDA being what it is it tries to find the medium, the happy medium. So you get good enough performance, but it's not the optimal because there's trade-offs. And this allows NVIDIA to change the architecture from one generation to the next quite a bit. Right. And so that's why NVIDIA is the king of gaming because they've made this CUDA layer so that it works with really old GPUs from 10 years ago and something new in the future. Now for ML and AI, you don't need all that stuff. You just need to figure out how to parallelize your work so that it runs as fast as possible. And if you bypass CUDA and go back to the driver, you could do it if you have the expertise. But in reality, most programmers don't have that expertise. I mean, that's like my guess would be less than 1% of engineers have that skill.
DeepSeek did something similar. They skipped the CUDA layer and went to the
PTX.
layer above the libraries, right? What's that?
Yeah,
Or
the
the drivers?
PTX. Yeah, so internally, CUDA compiles it down to PTX, and PTX generates the execution code.
Okay. And this Mojo skips all that and goes right to the execution code,
It goes right to the driver. Yeah.
right to the drivers. Okay.
Yeah.
So when you're building or using a model on an old hardware, it sounds like you're also on a different version of CUDA. If you go to a newer hardware, you're on a slightly different version of CUDA. Does the
Yeah.
model usually work okay?
It does because it
Okay.
makes sure it's compatible.
But what you're saying is that as CUDA's gotten bigger and bigger and bigger, it brings along with it a lot of the legacy stuff so that
Well, it
it's
has to.
portable, right? So
Yeah.
you can run a model on old hardware or new hardware. And that starts to get fat after a while. And you don't, as the ML engineer, you don't need it all.
No, no, because you
Right.
want the latest hardware.
Whereas Mojo basically says, I don't care if you're running on NVIDIA or AMD or Grok, I don't care.
Yep.
I'm going to do the work to make it work on the new hardware. And we're going to keep this thing nice and lean. And it's just going to be our job to make it all work. How is it different than Grok? How come it doesn't get fat?
Well, so it's different from all the
Not
libraries.
Grok. How is it different than CUDA in that it doesn't get
So
fat?
so
Sorry.
CUDA is really a high level kind of application specific library with stuff for genomics and graphics and AI and so there's all these libraries on top, and then beneath that there's a bunch of like math libraries. So um the common one that everyone uses is the linear algebra library, which does all the matrix math. And so everyone at some point calls that library, right? But it's not that simple because you have to know how many CUDA cores there are, how many tensor cores there are, and you have to map your processing to the correct number of cores of each type of processors. And then you have to load the memory correctly. You have to preload stuff correctly so it fills the pipeline correctly. And then you have to do all this like fancy stuff to figure out like, okay, what's the most optimal way to load the data and train? So DeepSeek went, okay, we're gonna skip all that CUDA stuff. We're gonna go PTX. We're gonna tell it exactly what to do. We're gonna keep the memory of the weights that we need in memory, and we're going to take the data and we're going to shuffle that in and out. Whereas in CUDA, if you just said train, it'll shuffle everything. So it'll load the weights for the model and it'll unload it to load something else in. So do this thing of shuffling data in and out, in and out, in and out, and so that ends up wasting a ton of time.
Are you or will you use this modular stack with Mojo and Max? And
Yeah, so I've been playing with it. It's been out for like 2 years, and when they first released it, they're like, "This is open source. We want to try it, but it's not quite ready for prime time yet." And this year, they finally reached a point where at their conference, Chris said, "All right, for 2 years, I've been telling people don't use it yet, but now I'm ready to say everyone go and use it." So they've reached the point where they're ready for prime time.
then do you think that'll be a game changer for people like you that are building models and deploying on hardware?
I think it's a game changer for the industry, period, because now you have options.
And
Because
what is that? What's the benefit of having options?
well, so for example, back in 2023, George Hotz of Open Drive, the kind of the open source autonomy software for cars, tried to get his stack, Tiny Grad, to work on AMD, and he spent like I don't know, like weeks, and it just kept crashing. And he finally messaged Lisa Su at AMD, said, "Hey, your drivers suck." Then I think a day or two later, Lisa had someone from AMD contact George, and George sent him the error. And within I think a week or so, they gave him a new driver and it worked better. And so now, thanks to him and other people at Meta and just the people in open source, have been trying to help AMD make their drivers better for machine learning. But it's taken over a year, right? So George did this experiment in late 2023. 2024, he got kind of serious. And then this year, finally, 2025, it's getting to the point where it's actually stable now. But so it took, over 2 years.
Good. Well, I'm excited to see as you play with it more and more if it's kind of the platform that, serious people will just kind of default to just because it's so portable and agnostic and.
Yeah, I think for a lot of people they will, but if you're GPU rich, you probably won't bother. But like GPU rich is like what, 6 companies.
Right, right.
Everyone else is GPU poor. So
By the way, how does this modular company make money?
they're gonna license out their Max and their Mammoth platform for people that are companies.
Got it. So anyone that's doing massive inference or
Yeah, startups, whatever.
yeah, got it. Okay. Cool. Great topic, Peter. Thanks for educating us a little bit. You can find us, just so you remember, we can find us on Spotify. We're there. We will take questions or topic ideas if you have them. Leave them in the comments and we'll get to it. We'll talk to you next time. Thanks, Peter.